chapter 12. I will continue from problem number 5. Problem number 5 says a cyclist moves from O to D, moves from O to D along the path as shown, along the path as shown. The distance covered by him so the diagram is, this is a point O. From here he has moved to A first, and the direction is this one, 8 kilometer is there. Then after, from A downward to B, in this direction, and then from here to C in this direction, 3 kilometer, this is 4 kilometer, and from here again 1 kilometer at point D, 1 kilometer. So now we have to find the distance covered by him. So as it is distance, it is not associated with displacement, it is very easy to find. So the distance is OA plus AB plus BC plus CD. So if we add it all, we will get the result, 16 kilometers. So this is it. So there is nothing much. It is a very simple problem that I am explaining, just to give a feel of how you do calculation of such problem. Okay, now moving to number 6. A book is kept. A book is kept on a table at rest. The book is moved. The book is moved through a distance of 8 centimeter along the edge of the table, along the edge of the table. If the table is moved, if the table is moved through a distance six centimeter, in the opposite direction of the book, with respect to the floor, with respect to the floor is how much? If the table is moved through a distance of 6 centimeter in the opposite direction, mm, opposite direction, then the displacement. Oh, now it is then the displacement of the book. Oh, I forget to write then the. Let me write it again. Direction, then opposite direction, then the displacement of the book with respect to the floor is how much? Okay, so let me read it out again. A book is kept on a table. Let's say this is a table. A book is kept on it. Okay, at rest. It is kept at rest. This is a table on which a book is kept. This is its leg, and this is the book. Okay. At rest, the book is moved through a distance of 8 centimeter. So let me assume that the center line of the book is this, and this is moved by a distance 8 centimeter along the edge of the table. So it is following the edge, let any of this edge, because table, if you see from the top, it will be seen like that, and it has must have 4 legs. And if this is the table, and on which, let's say this is table, okay, so on which a book is kept, this has moved from parallelly to the edge, any of this edge. So I am just trying to have feeling that it has moved to a distance 8. Okay, along this edge. This is one of the edge. So along this edge, this has moved. Okay, this distance. This is the center line of the book. Same is represented here in 2D and centimeter along the edge of the table. If the table is moved through a distance 6 centimeter in the opposite direction, so I am assuming that book, the initial position is this is final position. So book is moved in this direction, the displacement of the book is this direction. Now the table is rest, the initially both are at rest. Now book is moved this way, so its final position will be somewhere here. Now the table, which is as initial position this is moved in opposite direction, means book is moved this way direction and the table is moved in this direction. Okay, so once it's moved, so it's got a new position here. Now the table is moved by 6 centimeter, so its final position from here, it is 6 centimeter along this direction. So why the book is first moved, so it has reached somewhere this, with reference to this, if I take this leg is the reference, so the position of the book from any not this one, I assume that center line of the book is the reference. So from there, with respect to this, it has moved 8 centimeter. Okay, now from this the table, So this is also a point on the table. This is also point on the point, any point on the initial position of the table lies on that. So if table is moved by 6 centimeter, then this line with respect to that, this point will move by 6 centimeter again. Any point is there. So the ultimately as book is on the table, so this is not different. So their motion is always goes together if the reference frame, because table is your reference frame and book is the object moving, but this object is lying on the reference frame itself. Now when book is moving, so it can be, and both are in standstill initially. So when book is moving, table is also in rest, so his movement can be seen with respect to this table by 8 centimeter definitely. But when table started moving, the book is on the reference frame, so separately those are not separately moving. So when table is moving 6 centimeter, at the same time table which is resting on the book which is resting on the table also move by 6 centimeter on the opposite side. So ultimately book has moved by self to 8 centimeter, and due to the motion of the table on the opposite side by 6 centimeter. So as this is a displacement, I have to count. So displacement, the total displacement is for the book. We have to calculate the book's displacement of the book. So the book initially moved 6 centimeter on this direction, and while moving the table or opposite direction by 6 centimeter, the book also move along the table, and that will be like that. So that individually, if I consider for a book movement, that is 8 centimeter right side and 6 centimeter on the left side, that will be count as a negative, because we are considering the displacement, and this displacement is nothing but the initial position to the final position. The final position when it is moved 6 centimeter, so that is 2 centimeter from its actual position, from where the book is moved by 8 centimeter, and due to the movement of the table, the book again come back to 6 centimeter, because everything along with the table which is associated with the table will move back by 6 centimeter, and that is told to be in opposite direction, so it will move on the opposite direction. Now where the book has moved initially by 8 centimeter, so ultimate displacement will be 2 centimeter in the same direction it has started moving 8 centimeter. Okay, so it will be signed by because this is displacement and this is a vector, so I have to give a sign this one. Okay, now moving to the next problem, number 7. An aeroplane moves 400 meter towards north, three hundred meter towards west, and then 1200 meter vertically upward. Then its displacement from the initial position, from the initial position is how much? Is how much? So an aeroplane moves 400 meters north. Now you know the directions. This is north, this is east, this is west, this is south. Moves 300 meters. Let's say this is 300 meter. No, oh sorry, 300 meter north. Starting from a point 300 meter north towards no, this is 400 meter. Sorry, this is 400 meter north. Then 300 meter towards west. So let me start from here. 400 meter north direction, then 300 meter west direction. Okay, 300 meter west, and then for 1200 meter vertically upward. So it will not be sufficient. Again, I have to rub it. I have to get the area. Then let's say this is the point. This is 400 meter. This is 300 meter. This is 1200 meter. Vertically upwards. That is displacement from the initial position. So this is final. This is initial. Now if we add it together, so this will be your displacement. Let's say this is A, B, C, D, and the intersecting point I name it E, because that will be needed afterward. Now what would be the value of this? Now this can be done by calculating this triangle separately, or you may do it like that. This is parallel vector, this is displacement vector. So if I draw it like that, I will bring this parallel here, I will shift it here, okay, and this I will shift it here. Now see, this is turned to a single right angle triangle, isn't it? Because any direction or any two directions are perpendicular to each other. So if it is moved here, so this is now it is 300, because parallel vector, the parallel shift is applicable for vectors. So I will shift this vector of value 300 here, and then put this vector there without disturbing the directions. This is direction, this is also put, this is direction. So now your result will be this plus this will, and the resultant vector will be this one, the displacement, the ultimate displacement. So how do you find that? This is right angle triangle. Now if you consider this is 3, this is 4, this is 12. So this A and the position here, it is D. AD will be somewhat, because all is multiple of 100. So I will not calculate 100. I will keep it outside. And what is that? This square plus this square. So this square means 3 square, and this together it is 16 square. Okay. So now this is 100. 3 square means 9, and 16 square means 256. Isn't it? Am I right? 300, 400 plus 16. So 16 into 16 is how much? 256. Yes, 256. So this is 100 into 256 plus 9, that is equal to 265. 265 is, if I factorize, how much it will come? 5 5 0 5 3. So no factors is coming. These are two factors. So this will be the value of the ultimate, this is the ultimate displacement in meter. So this is the how this is displacement between the, from the initial position. This is the value of that. Okay. Okay. Now move to the next problem. Problem 8. A carom board cm cross 40 cm has the queen at the center. When the queen is hit by the striker, is hit by the striker it moves to the front edge. It moves to the front edge, rebounds and goes back and goes into the hole behind the striking line. The striking line. The displacement of the queen is how much? So let me read down again. Read it again. So the carom board. So let me construct the carom board. You might have seen, you all have seen the carom board because all might have played. So there is a line of striker from which line you have to start. You cannot cross this line to strike. So you have to keep your striker here on the line. In which direction the player is sitting. These are the pockets. Okay. Now this is the center where the queen is sitting. This is the queen is sitting. Now your striker, you are striking with the striker. It moves the front edge. When you strike from here, let's say you are sitting here, okay, and you are striking, and it will move to the front edge, either from on this wall, on the wall. The front wall is this one, and the front edge where the something will strike and come back is the edge, the front inside edge of the wall. So it may, when it will strike, it may hit this way and move this way or this way, or so I can show the path by which it may move. This could be the two possibilities. If it is rebound, so it has already shown it is rebounded on the front edge and goes into the hole behind the striker's line. This is the striker's line from where he will strike, either this side or this side. Okay, so if you strike, the striker will sitting on the striker, either on this point or this point. So this is the only possibilities. When it is rebound back, it will either go to this or this. This is the situation or the scenario of the sum given. Now I have to find the displacement. So any of this path, because this path could be mirror images to each other, either you follow this or this follow, because the board is of 40 cross 40 Okay, and the carom board is a 40, but this distance nowhere it is mentioned. If I even assume this is x distance, equidistance from all sides, let me assume, if in case it is helpful to that, so I will assume x. So I will follow this path because this is symmetrical about the center axis. If you follow this or this, the result won't change. So if I follow this, it is center. Now the two center of it will divide into four part. So symmetrically, if I say it would strike somewhere at the center of the other half. If I consider the movement is happening in this part, then it must strike at the center, otherwise it won't get uh, sorry, no, not at the center. It should strike somewhere that this will get an angle to drop in the. So how is that angle look like? If I say somewhere else, if I drop a perpendicular from here on the other cross lines, the center lines, the transverse wise and the vertical wise, if I divide with the two center lines, it this triangle and this triangle and this triangle will be of similar triangle, otherwise it won't come to this pocket, because this is the angle by which it bounce, then only it drop. I think you might have got my point, because let's say this is again a obstacle, and if it is his back, it definitely will come to this pocket, otherwise if it is not moved this way, it will move on this pocket. So this is the only this can be compared with the light beam. Light beam goes in a straight path, that the same way the queen will move, because if it is not strike at the same angle which is making with this, because this angle should be same and this must be same, otherwise it won't follow, it put in the pocket itself. So from there you can say this triangle and this triangle are similar triangles. So if it is the case, then the distance it is traversed by this part will be equal to each other, because this is the center line, it will equal, it is a similar triangle, so the similar sides are equal, so this equal to this. But for the displacement, if this is taking a direction this way, this is on the opposite direction, you can say. So this is almost, it is on the northeast, so this is on the opposite direction to the northeast. Okay, this is on the opposite direction, this is, if it is theta, this is 180 minus theta, 180 minus theta. So if you take any angle, it will be opposite angle to this line. So displacement wise, this, if it is moving in some direction, this is opposite direction, and this is further to that direction, opposite to the initial direction. So this distance and this distance are equal, and as because these are in opposite direction, it will nullify each other. The only displacement is this one. Okay, now if we don't want to go this way also, then my as per the uh, definition of the displacement is that the difference between the start point and the end point. If I consider this one only, this I am considering for the distance traversed. Okay, now the displacement is the initial point to the final point. Okay, so now this central lines divides each other equal in four parts. So these all are again the four squares, as it is 40 by 40, so this will be half of that 20. So each of this part will be 20. So now what is that? This is the diagonal of the square, and this will be the displacement. Now if I consider the displacement, so this will be the, if I consider this as a right angle triangle, is a half of all directly you can say, if it is a square, the diagonal is nothing but root 2 into a diagonal. If it is root 2a, so what is a here? A is the side of the square, it is 20. So you can say the displacement is 20 root 2. And if I consider the distance, this is this distance and this is this distance plus this distance. What is the distance? As I said, this is equal similar triangle. So how can I find this? This distance, if you closely observe, this is one this distance, this is half of the half. That means if it is again half of this one edge of this square, this is 10, this will be further 5, because the angle of rebound should be such that it will reach there. So from the symmetry you can say that this is equal to this, because this is center line of the further squares, and this will pass through the center of this half. So this will be 5. So if it is this 5, this is 20. So this length in single length will be equal to under root of 5 square plus 20 square. So if I take 5 square common, this will 5 come out, 1 plus this will be 4 square, that means 16, 17. The 5 root 17 with the value of this one part. Now it is 3 times it is coming. So ultimately the distance traversed will be 3L, that is equal to 15 into root 17. Although the distance is not set to calculate, but even it is more tougher if somebody tell you to calculate the distance, and this line, the distance will not be in use. That's why it is not mentioned, because the only thing is that it is striking at the edge and coming back. Okay, so just consider another how I come to that. It is rebounded this way and this way. So if I take this triangle, bigger triangle, to this triangle, this will be parallel lines, and this will divide into similar triangle. So if I take this, so this must be striking somewhere at half to half of that, because if it is striking somewhere else, it would not able to reach there. From the symmetry you can say that. Okay, so this must strike at 1/4 of the half, definitely, otherwise it will not be able to reach this distance. Because how can I that, let me draw the symmetric triangle, because it need to be understood properly. Let me draw it again. This is a square, the center of that. So if I divide it along 2 axes, so now the pocket is here. So now the angle must be somewhere here. Now if I don't assume it, this is parallel to this, so this by total will be this by this. Okay, so now half is 10 by 20 is equal to this by this. So this distance, let me take is x. So this is x. So this I am taking x1. Oh sorry, this will be x1, then x. The more will be x1 x. So this is how much? X1 is equal to x by 2. X1 will be x by 2. Okay. So from there, if I draw this triangle, so this must be, this two triangle must be similar. This must be similar triangle, because this parallel to this is a common line. So this it will be a similar triangle. And now again this is bouncing, that means you can assume that this triangle is similar from the symmetry, because it is bouncing back, it will form equal angle. This is 90 and it will form equal angle here. So from angle side this will be similar. So this similar to this similar to this. From there you can say this side equal to this side and equal to this side. Now if I assume this is to this and this is to this, again it is a half. So this could be the half of that total. So this will be the half of that total. So this diagonal, if I take, the total is d. So this part will be d by 2. Okay. Now what is the relation between this and this? So d square will be x square plus 20 square. Now if it is again d by 2, so similarly this is 10. So from here, if it is d by 2, as because from the symmetry, d by 2 whole square equal to this, I don't know, this will be somewhat 10 minus x whole square. This is total 10 x minus, so this one plus 10 square. Okay, so from there we can say it is 10 square 2 into 10 square plus minus 2 into x into 10 plus x square. So d square is equal to again x square plus 20 square. So you can equalize this two. So this is x square plus 20 x square plus 400, I can say, equalize this side, because this d square is equal to this by 4, where this by 2 is equal to, here it is 2 into 10 square means 200 minus 20x plus x square. From there we can say x square x is cancelled out. So 20x is equal to something, 20x is equal to 200 minus 100, that means 100. So from there is already can be said from the symmetry, but even you can calculate it. So x is how much? 100 upon 20, so that is equal to 5. So x I have considered to be 5. What I have taken as x is d square is equal to, this is d I have taken total, x is this one, so 20 square 20 square. Okay, now again d by 2, this is d by 2, 10 minus x, this one, that is plus 10 minus x whole square 10 square equal to, this is equal to, so this has again, so calculated x. So this distance is coming, x is equal to 5. So if it is 5, so that means has to strike somewhere there and come back. So x is 5. Am I calculating somewhere wrong? This is x, this is x. So from there I told that this is to this is equal to this is to this. Okay, definitely. So this equal to half of this total, d by 2. So if I take d by 2, this one is equal to 10 minus x. If we consider x is equal to, d square is equal to x square plus 20 square. So 400. Oh, 400 is this way. This is 400 by, oh, sorry. I've done mistake here. Sorry. So this is x square plus 400 by 4, and this side it was x square was there, 20x was there, and then plus 2 into 10 square is there. So this is not cancelled out. This will be converted into x square by 4 plus 100 equal to x square minus 20x plus 200. sorry, I have mistaken. So let me rub it out. Now this thing you have understood, that diagram. Now consider the calculation, x square minus 20x plus 200. So ultimately x square will become this side, so 3 by 4 x square minus 20x, and your 100 plus 100 will be there. So everything will rub it out. So ultimately 3x square minus 80x, this is 80x plus 400 equal to 0. Now if I calculate, x is equal to minus b plus minus b square minus 4ac, that means 12 into 4 into 4, 1600 into 3, 16, 40, 100, 0, 0 by 2 into 3, 6. So 80 plus 80 square means 64 square, 64, 0, 0 minus 48, 0, 0, that will equal to 14, 8, 6, 1, 1600. Okay, by 6. Now if I take minus, minus will not give anything. 1600 means 40 will come. So 40 if I take minus, so one result will come. If I take plus first, 120 by 6, so that means 120 by 6 is nothing but 20. So this is not possible, as because x cannot be equal to the whole length. So the minus is possible. So 40 if I take, so 40 by 6, 40 by 6 will come. So that means 20 by 3. Okay, so this will come around 20 by 3, the x distance. Now if it is known, then x is known, so what will be your d? D is nothing but d square is equal to x square means 20 by 3 whole square plus 20 square, d square from that diagram. This is d, this is x, this is 20. So d square is equal to x square. So x is equal to, I have got already this much. So this is 400, means 20 square you can take it out. 20 square, it is 1 by 9 plus 1, isn't it? So d is equal to 20 by 10 by 3. So d, so this is d, another d by 2 will be added when it is started from center. So the total distance will be d by 2 plus d, that means 3 by 2 d. Okay, now if it is so, so d I have got how much? D I have got 20 root 10 by 9 by 3. Okay, now 3 d by 2 is equal to 3 by 2 d is equal to, that total distance is equal to 3 by 2 into 20, 10, so 10 root 2, 10 root 10. So this will be your ultimate distance covered by the queen up to the your pocket, if it is at all to be calculated. But I have done it even if it is not there. But this is the toughest part in that, where you have to use your geometrical sense then only. And displacement is very easy, because from center the pocket is at the diagonal distance of the 1/4 of the whole carom board. So this is very easy to find. So that is nothing but root 2a. So that is a, you know. So from there you can easily understand. So this is for now. The next video I will bring the next problem. That will be the problem number 9, and your chapter will be number 13. Okay, thank you.